Hello. In this kind of demonstration, I'm going to be showing how to do expectimax trees, pruning them. So pruning can only occur if there's a bound, and for this specific tree, we have bound between -2 and 2. And what you want to do is you want to propagate this value from the root node down the leftmost subtree until we reach a leaf node. So as you can see, we're propagating the values down, and we end up at -2, 2. And do we have enough information to prune anything at the moment? No. And before we start pruning, I just want to kind of explain what this -2 and 2 is. It's just basically the range of values this tree can take. So our worst case scenario, our leaf can return -2, and our best case scenario, our leaf can return 2. Now that we know that, the next parts are a bit more intuitive. So next we have our leaf node coming out to be 2 and 2. And now we are at a minimizer function. This is a minimizer and this is a maximizer. And in our minimizer function, we're going to be picking 2, of course, because that's the only value we can pick over here. And we end up with our range 2, 2. And that makes sense because our minimum value and the maximum value, both in this scenario, is going to be 2. Now, however, we have a small issue over here. Our range over here on the parent node is obviously going to change because there has been a change in our child node. And in order to do this, we also need to know what would have been the range over here, and that's pretty simple. That would be -2, 2. And I don't know why the slides don't show this, but we have -2, 2. And a lot of people think, oh my days, how did we end up with 0, 2? And that's pretty simple. We just use the probability function and of what we would get on this branch and this branch, and we can compute the worst case scenario to find the lower bound and the best case scenario to find the upper bound. On this particular branch, we know that the best and the worst is going to be 2, so it doesn't really matter. But on this branch, we know that the worst scenario is going to be -2. So if we pick 2 and -2, with a 0.5% probability, 2 times 0.5 will give us 1, and -2 times 0.5 will give us -1, and when we add them together we get 0. And the same thing when we try do max to find the maximum range. We do 2 times 0.5 and 2 times 0.5, which gives us 1 and 1, and we add them together we get 0, 2. And in order to find, I give a generalized formula on the side which the slides are missing to give you guys a better understanding when you guys need to watch this down slowly later. Another important thing, you're wondering from alpha beta pruning why we don't propagate these values down. Like a lot of videos online will show you to take the parent node now updated and then put it down, propagate those values down until we reach. No, we do not do that for this kind of pruning for expectimax trees. We only update the parent node if we detect a change in the child node. Bear with me, guys. So now we have -2 plus 2. Can we really prune anything here? No. So then we take the next two leaf values over here and we get 2, 1. And we're wondering, okay, based on this, what is our minimum value we can take? Because it's a minimizer. And our range instantly turns to 1, 1. We have now seen a change in the child node, so we need to propagate that change to the parent node. And using the same formula over here, we do 2 times 0.5, 1 times 0.5, which is going to give me 1.5, and then for the best case scenario, 2 times 0.5 and 1.0.5. Notice over here, because we know the min and max, we know the exact range, so both the minimum and maximum expected range is going to be 1.5, so, which makes sense. And now we know that for this subtree, the best value we can return to max is going to be 1.5. That means we can safely say that this root node is greater than 1.5. And why is that? Because if we were in this subtree, we got a value which was, let's say, one of the branches evaluated to 1.0. Let's just say evaluated to 1.0, we can safely say that max will never ever choose that tree, so all the other branches of this subtree can be pruned safely. So that is how this type of pruning is very powerful. Only if we have bounds, guys. Once again, only if you have bounds. So now we propagate the values, like I said, we don't take this value, we take whatever the bounds are, and then we propagate it down to the leftmost child. And now we get the value 0. This is very interesting because this gives us a possibility of pruning. We change our range because we don't have both our values. We can only change, we can change only one of the bounds. So this becomes -2, which is our worst value possible. And our best value possible now is 0, because the minimizer will pick 0, of course. And then, of course, we have a change in the child node. So hence, we can now have to propagate those changes back to the parent node, which is going to be -2, 0, -2, 2 over here. We multiply the values, so it's going to be -2 times 0.5, -2 times 0.5. We add them up, -2. That's our worst range for our parent node now. And for our best node, which is going to be 0 times 0.5, and what's the code over here? 2 times 0.5, we're going to be getting 1. So our new updated value is going to be -2, 1. And now we now look at the maximum value over here. And we see, oh boy, we end up with our maximum value being 1, which is smaller than 1.5. So we can safely say that we can prune this branch over here. We don't need to evaluate this anymore. And we don't need to evaluate this branch anymore. And that's kind of everything there is to expectimax. And usually you will be having to do this every single time you have done a leaf node. But over here, I just know there's no pruning. But you would have to do this evaluation, check, and then check against our current greatest alpha at the moment. So yeah, hope that makes everything a bit more straightforward. And yeah.